Hello everyone, let me introduce myself. My name is Ryan Bagus Maulana. I am a student at Polytechnic Negeri Jakarta. On this occasion, I will demonstrate my final project entitled Design and Simulation of Link Budget Analysis System for Multi-Orbit Satellite Communication using Deterministic Algorithm based on Visual Basic. Practically, the output of this final project is Orbitlink Studio, a multi-orbit satellite link budget simulation application that comprehensively analyzes network visibility. Orbitlink Studio acts not only as a mathematical calculator, but it has also been integrated with a validation expert engine, or a rule-based expert system. This system is capable of detecting violations or physical constraints and ensuring our design complies with industry standards such as I2R and FBS2. Upon starting the application, we will see the homepage which provides option to view the user guide, about, and contact. So let's start with pressing Start Simulation button. First, we can choose the simulation mode. The options are new satellite and existing satellite. If we choose a new satellite, we will then select the type of satellite we are designing: one-way communication satellite, two-way communication, and navigation satellite. If we choose an existing satellite, we need to select which existing satellite we will use for this design. As an example, we will choose a two-way communication satellite. And we will enter to the geometry panel. In this panel, we will input the coordinate of the user or Earth station and satellite coordinates. First, we press the Open Map button and pinpoint the user's location. Second, we press the Open Satellite Map and search for the satellite we will use as a coordinate reference. We do this because satellite coordinates is important, so we use the reference coordinates to ensure calculation precision. Once the reference satellite is determined, press pause to the satellite stops moving. Click Info and select current position. Manually enter the satellite's coordinates into the text box. Don't forget to input our ID2 and our ID text box. After that, choose the service type according to the desired design. Press the Calculate button. And next, we proceed to the main calculator by pressing the Open Calculator button. In this demonstration, we will demonstrate with 4 scenarios covering 3 different link visibilities. Let's get right into the first one. First with the scenario 1, to facilitate the demonstration, let's define the parameters to be used. Here are the parameters we will use. We will start with the geometry. We will input the demonstration parameters that are announced. Let's input the parameter. To view the geometry results, press the Calculate button and then move to the calculator with pressing Open Calculator button. Because this demonstration uses a two-way communication satellite type, we must fill in the downlink, uplink, and digital tab. However, if we choose a one-way satellite type, the uplink parameter tab will be disabled. In here, you can see a guide button to help users to input their parameters. This assistant complies with industry standards, and the values adjust dynamically to the type of service select and the satellite orbit used. Okay, let's input the downlink parameters according to scenario 1. Once done, we press calculate button. Next, move to the uplink tab. Input the scenario parameters. And click calculate button again. Next, we enter the digital tab. Here, there is also a help button. And let's fill the parameters according to the scenario. Alright, press calculate button. And let's move to the results tab. Here, we can find a summary of our design and, most importantly, the visibility result of the link we designed. We can also visualize our satellite by pressing the satellite visualization. And last, we can export our design into an installation technical document by pressing the print button. In this document, we can review all the parameters used, the link status, and the standard values. Okay, that is for scenario 1. Let's move on to scenario 2. Okay, just like the previous scenario, to facilitate the demonstration, we determine the parameters to be used. Here are the parameters. First, we will select an existing satellite, which is MESA 3D. For existing satellites orbiting in GEO, the satellite coordinates will be automatically filled from the database because GEO is static. If we select existing satellites orbits in non-GEO, we need to input the satellite coordinates manually by checking the reference on the satellite map. Alright, we input the geometry parameters. Click calculate button. And then enter the main calculator with pressing open calculator button. Now input the downlink parameters. Press the calculate button and move to the uplink tab. Okay, input the uplink parameters. Click calculate button and move to the digital parameters and input the digital parameters. Okay, calculate the digital parameters and move to the results tab. In this scenario, we intentionally defeat one of the parameters from the industry standard, specifically the satellites NF. We can see at the result, even though the link margin is above 0, the status will show visible with warnings. We can also visualize the satellite. Here, the MEASAT 3D satellite that we are using is directly visualized. Then we can print our design results into technical installation documentation. We can see at the top of the document, we can see a warning detailing in this design. Okay, that is for scenario 2. Let's move on to scenario 3. Same to the previous scenarios, let's determine the parameters to be used. Here are the parameters. Okay, we will start with the geometry. You can see a difference here. For navigation satellites, we calculate one additional parameter, which is the target beam width. Okay, let's input the parameters. Okay, let's calculate this geometry. And then we move to the calculator with pressing open calculator button. Okay, since a navigation satellite operates one way and transmit ranging codes and spread spectrum, we only need to fill in the link parameters. Okay, let's input the parameters. Okay, if done, click calculate button and then check the results tab. Okay, in here we can view the design summary, and just like before, we can visualize the satellite with pressing satellite visualization. And print our design results into an installation technical document. Okay, that is for scenario 3. Let's move on to scenario 4. Again, to facilitate the demonstration, here are the parameters. First, we will select an existing satellite, which is a GPS satellite. Because GPS satellites orbit in known geo, we need to look at the satellite coordinates reference on satellite-map.space. Because this is a demonstration, we will just input the predefined demonstration parameters. Okay, let's calculate this geometry. In this scenario, a notification warning appears in the system. I intentionally configured the resulting of elevation angle to fail the navigation standard. The system rule also applies to communication satellites too. Here are the standards. Next, we enter the calculator. As you can see, because the existing satellite uses spread spectrum modulation and sets a standard minimum signal strength, the simulation focuses on visibility against atmospheric attenuation and multipath effects. Alright, let's fill all the parameters. Okay, let's calculate this and look at the results that we can see. Even so there are no deviating RF parameters and the link margin is above 0, the overall link status shows not visible. And because the link is not visible, the system prevents us from visualizing the satellite. However, we can still print the design results into an installation technical document. In the document, we can see a fatal warning indicating that the elevation angle is below the regulatory standards. Alright, that was a demonstration of how Orbitlink Studio works as an expert system. In reality, this application have many layers of standardization and dynamic validation parameters that are impossible for me to show one by one in this short video. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.